This is the second video for the sine law, where we're going to delve into what really makes it a little bit more complicated to deal with than you'd expect. So at the end of the first video for sine law, 2.3.1, I talked about how even though the law itself is pretty easy to calculate stuff with, it does tend to have issues where things get a little bit more troublesome. So before we get into it, let's just quick refresh ourselves that the sine law is sine A over A equals sine B over B equals sine C over C. And so the reason that the sine law gets a little bit more troublesome is that we have this thing called the ambiguous case, which means that sometimes the sine law isn't always going to have a clear-cut solution. There's a possibility, depending on sort of how your triangle is set up and what information you're given, that the sine law will have 0 solutions, or 1 solution, like we saw in the first video, or 2 solutions. 0 and 1 are both pretty easy to deal with because, well, 0 solutions means you just don't have to do anything. 1 solution is what you already saw, but 2 solutions is going to be quite a bit more work. So in this video, I'm just going to go over how to figure out how many solutions something has and sort of like why these cases occur. I'm not going to get into actually calculating 2 solutions until the 2.3.3 video. Before we get into this too much, a quick note. We only even have to consider this, so the ambiguous case only occurs when you have 2 sides and 1 angle. So if you have 2 angles and 1 side, you're automatically just going to have 1 solution and everything's easy and happy and great. It's when you have 2 sides and 1 angle that you have to actually put some thought into this. All right, so let's assume that we know 2 sides. So we're going to know sides A and B, and then we also know angle A. But we're not given an exact description sort of on how these things are set up. So with that being the case, this is going to be my side B right here. So I know exactly how long it is, and I'm going to kind of build around that so I know where it is. Side A is going to be attached to side B over here. So this is going to be my side A. The problem is I don't know exactly where it is because I don't know the angle up there. So I'm just going to put it over here for now, and I'm just going to call this side A. So we don't know where this is. We know it's attached to side B right there. We don't know which direction it's pointing. Angle A is going to be down here then. And so if I know exactly how big angle A is, so say it was like 30 degrees or whatever, I would know that there's got to be a line here, but I don't necessarily know how long it is. We don't know this side length. We just know that side exists. So we know there is a side down here. We just don't have an exact number for it. So it could be sort of any length along here, depending on what I'm dealing with. So you kind of think of it as like you're building a triangle that uses the ground. You know where the ground is, but you don't necessarily know how far along the ground your triangle is going to reach. And so this is sort of our setup. This is what we know. And again, we don't know how long this is. One last thing, for some of our things that we're going to be dealing with here, the height of this triangle, the height just being the distance from the top on down, is going to be helpful for some things. So this dotted line here that I just added in, this is called H. And we can get it using just a really simple formula of B times sine of A. And that's just like coming from grade 10 trig. I'm not going to go over the whole derivation of it, but just trust me, B sine of A. All right, so I've actually got a printout of some notes here. These notes should be available in the description of this video, so if you just check for a link, there should be one there that will take you to a Google Drive. If you don't see one, maybe just shoot me a message and I can always send you the file directly. So the ambiguous case of the sine law kind of has multiple options, and then each of those options has multiple cases, to the point where you'll see this more later, but I've actually created a flowchart that kind of guides you through the whole process. So you can see there's lots of different places this can go. So our first option is if this given angle, angle A, this one over here, if this angle is acute. So that's how we've drawn it here. So we've got an acute angle. So we've got sort of this setup, and again, we know that h equals b times sine of A. And so we're going to run through a bunch of different cases depending on sort of how the side lengths relate to each other. So our first option here, if side A is smaller than that h value that we calculated. So that means we have a pretty small length for side A. So the specific length doesn't really matter, but just, something like this. So if we were to kind of rotate that back and forth, keeping in mind that this bottom length down here, this is part of our triangle, you'll notice that that length never actually reaches the bottom down there. And so we don't actually have a triangle with this. So let's visualize this in a slightly better format. So once this loads, here we go. So this demonstration just shows the same thing. I'll tell you right now, for this particular demo, h is just 10. So try to keep that in mind. H is 10 for this one, and that's not going to change. So right now, A is too small. It does not reach that bottom line, and it doesn't make a triangle. And so what we end up with here, since A never reaches the opposite side, that's what we're going to put in here. So A doesn't reach the opposite side, which means we have no physically possible triangles using the information we have, and so there's no solutions. So imagine that I told you that, side B was a meter long and side A was only like, say, 10 centimeters. And if you angled side B up enough, that 10 centimeter line is never going to be able to reach down below, especially if you're thinking of this like in terms of the ground. If we made A a little bit longer, so if A was the same length as H, well, if you rotated that around, and pardon my poor drawing skills, but it would touch perfectly when it lined up with H, right? Because they're the exact same side. So A is going to touch the opposite side at exactly 1 point, which means we're going to have one solution. And so if we try extending this out a bit here, right? So if we make A go all the way up to 10, we can kind of see that in action. And so you see here, right, it makes one perfect right triangle. If we made it even slightly smaller, like say 9.9, well, that one doesn't quite reach, right? So it doesn't get there. But with it being 10, it reaches perfectly. And so we get one solution. So what if we make it bigger? If we make A really big, so if A is bigger than B, so let's say it reached all the way over here. So it does touch there, and it does make one triangle. But if you swung it around over here, since it's bigger than B, the only other place it's going to touch would be back over this way. And that doesn't actually count for us. We don't consider that as making a triangle because we knew this angle had to be here. So we can't be using a triangle that's over on this side because that doesn't use the angle that we were given. So this doesn't count for a second triangle, but it does touch in at least one place, right? We've got a triangle over here. So A touches in one spot. And so we've got one solution. So let's go take a look at that. So if I make A big, so bigger than B in this case, if I make it all the way up to, I don't know, let's say like 25 or 30 or something. So we can see it touches over there on the right, and even though it touches on the left, that doesn't count because it wouldn't be including that 30-degree angle that we've got in there. And so there's our one solution. Where this gets interesting though, on that sheet, we've got a last row where A is in between H and B. So in this case, if H is 10 and B is 20. So if we get anything in between those two things, like say 15, let's see what happens. Well, now this is touching in two places, right? So it reaches on the right, and because it's smaller than B, it doesn't quite reach all the way that B does, but it's bigger than H, so it reaches past H. And so we end up making two triangles, so one of which reaches here, and one of which is going to reach over here. And so these two triangles are two valid solutions that matches this question. And so this is the only time we end up with two solutions. So when A is in between H and B. So A touches the opposite side in two places. And so we get two solutions. So that is all of the possibilities for when A is acute. So now we're going to look at what happens when A is obtuse. Thankfully, it's a little bit simpler. So now you can see our drawing, our angle A is opened up a lot more. So when A is smaller than B, we're going to kind of run into the same thing we ran into on the last one, where, okay, well, if A is up here, and that's as big as A is, so it's smaller than side B, no matter how we rotate that, that's definitely not going to reach the bottom. And so just like before, we're going to end up with no solutions. If A is equal to B, that seems like it might work out, but if you think hard enough about that, that means A is going to overlap down here right on top of B. And so that doesn't make you a triangle, that just makes you a line that's on top of another line, because this wouldn't be here at that point, and you would just have those two things on top of each other. So that is also zero solutions. Even though it does reach, it reaches in a way that's not really helpful to us. So our last one is when A is bigger than B, and this does work, right? If you swing this out far enough, you're definitely going to get a triangle over there. And sure, we'll run into the same thing as last time where it would make a triangle on the left here, but we don't care about the left side. We only care about the right, so we do end up with one solution. And so those are your options. You have 7 different cases to consider here. So 4 cases when A is acute, 3 cases when A is obtuse. And so we kind of have to figure out which one best matches with what we're dealing with here. And this is where this flowchart comes into play. So this flowchart kind of guides you through the whole thing. So if we look at what we've got here, we see first question is A acute or obtuse. So that's automatically going to split you into either the 4 or the 3. And then from there, you're just going to kind of go through and answer a bunch of questions that guide you to specific things. So let's try putting this to work and see if we can figure out how many solutions some given questions are going to have. So for the following triangles, how many solutions are there? Or how many triangles are there, we can even say. All right, so let's start with angle A being 60 degrees, side A being 5 centimeters, and side B being 7 centimeters. So if we look at our flowchart, question 1 is A acute or obtuse? So our angle is acute, so we've kind of gone down this path. Question 2 then asks us, well, actually the first thing it asks us is to figure out what H is. So since A is acute, now we want to figure out H. And so we're going to say H is B times sine of A. So our B value is 7. Angle A is 60. And if you calculate those, you'll get 6.06 as your H value. So we go back to our flowchart and we say, okay, we have figured out H. Now we're just going to go down. So is A bigger than B? Well, A is 5 and B is 7, so no. Is A smaller than H? A is 5 and H is 6. So yes, A is smaller than H. So if we follow the yes path there, we end up with no solutions. And so to justify that, if we were answering a question, say, we'd probably write something along the lines of A is less than H, so no solutions. And there we are. So trying another one. If we had angle A was 57 degrees, side A was 13 centimeters, and side B was 9 centimeters. So if we flip back to our flowchart, angle A is acute again. So we're still on this left path. So we're back to here. We need to find H. So H is B sine A, which is going to be 9 times sine of 57, which is 7.55. And that gives us something we can work with now. So we have an H value. So if we go back to our flowchart, we've got H, so we go to the next step. Is A bigger than B? And so A is 13, B is 9. So actually it turns out that yes, A is bigger than B, which gives us one solution. So we go back over here. Since A is bigger than B, we have one solution. All right. So see if you can do this next one for yourself. So same idea, follow your flowchart. The letters are going to be a little bit different. So see if you can figure that out on your own. I will help you with it afterwards, but see if you can figure out kind of how to piece this together. Okay, so the really important thing to keep in mind here is what's A and what's B. So if you're looking at what you're given, angle A and side A have to be across from each other. So if we know angle A and side A, that means this has to be angle A, this has to be side A, because they're both M's. So the one where you know, the one where you know the pair, that is your A's. And then the other one is your B. And so if we look at our flowchart, we've got our angle is obtuse this time, so we're going to go to the right path. And then over here, we just have to ask, is A bigger than B? So in this case, our A, or our A equivalent, is 9, and our B equivalent is 7. So A is bigger than B. We have one solution. So we'd say angle M is obtuse. We wouldn't have to actually write that down, but it's a good thing to note. Side M is bigger than side L, which is basically the same thing as saying side A is bigger than side B, which means we have one solution. All right, so one more of these to try out, and then that'll wrap this up. So I'm going to tell you angle B is 47 degrees, side A is 11, and side B is 9. So see if you can figure out how many solutions this one has. All right, so again, we really got to be careful. Notice how you have angle B this time instead of angle A. So as far as we're concerned, when we're doing our flowchart, this is A, this is B, and this is A. It's kind of the opposite of what it looks like. So we're not really doing H equals B sine A. What we're actually doing is H equals A sine B. You can still write down B sine A as long as you plug things in properly. Just be really careful. So in this case, we've got 11 sine of 47. If we calculate that, that's going to be 8.04. And so if we go back to our flowchart, we've got that our angle is acute, which is why we bothered to find H in the first place. And then, okay, is A bigger than B? So remember, being really careful with the letters here. As far as we're concerned, A is 9 and B is 11. So no, A is not larger than B. Is A smaller than H? Nope. H is 8, A is 9, so no. A isn't equal to H either, so we go past that. Is A between H and B? So again, looking at what we've got, A is 9, H is 8.04, and B is 11. So yes, A is in between H and B, and we do have two solutions. So H is less than, so-called A, which is less than so-called B. So we do have two solutions here. It should technically be, if we were writing this properly, H is less than B is less than A, because again, the B's are the ones that we have the opposites of. So it's all reversed. So you've really got to kind of watch out for the letters when you're doing this. It's the easiest way to mess up. And so that does it for finding out how many solutions you have. So in the next video, which is going to wrap up Sine Law, I'm going to actually go over how to then get two solutions. And then after that, we've got one video on the cosine law, and then that does it for trigonometry. So go figure out how to get two solutions once you're ready.